Okay, today we're going to talk about the Carnot Theorem. I'm Roy Kang from Alpha Theta Chemistry. We're going to start from here. This is a triangle with its circumcenter here, found here. Not the circumcenter, I mean, these are perpendicular bisectors. They form 90 degrees. They form a perpendicular angle with the sides of the triangle, but also bisect them into two equal parts, two equal segments, what I mean. So here, this part of the triangle this part of the triangle we're going to call the opposite of A, so lowercase a, the opposite of B, so lowercase b, the opposite of C, so lowercase c. Okay, we're also going to set up the circumcenter, which is at the intersection of all these perpendicular bisectors. We're going to call it O, as you can see in this photo. Okay, now we're set up. Now let's get started. Now we're also going to connect the midpoints found by these perpendicular bisectors, which is here. This will be 2 over A over 2. This segment will be A over 2. This segment will be B over 2. And this segment will be C over 2. No, C over 2. So now we find that there are cyclic quadrilaterals inside the triangle, because this is actually a circumcenter, which means the triangle should be inscribed inside a circle. And inside the circle, we see three cyclic quadrilaterals. Now let's deal with the first one first. Okay, this one is what we're gonna do. Now from here, what we're gonna do is we're gonna find the area of these cyclic quadrilaterals using the Ptolemy's theorem. So what we can do now is, now that we know this is C over 2, C over 2, A over 2, A over 2, B over 2, B over 2, we can actually, as mentioned, use the Ptolemy's theorem. We're going to do that by multiplying several values, including we're going to do that by multiplying a few values. So let's start with cyclic quadrilateral number 1. Number 1 will be called number 1, and we're going to multiply y times C over 2 plus z times B over 2. This is going to equal R times A over 2 due to the Ptolemy theorem. Okay. We're going to do the same thing for the rest. So let's say quadrilateral 2 is this one. Let's do it with another color. This one. This quadrilateral, we're going to do the same thing by multiplying z times A over 2 plus x times C over 2, which will equal R times B over 2. Let's do quadrilateral number 3. Number 3, as you can see, will be this one. The area of number 3 will be similar to the other ones. X times, let's see, this way, B over 2 plus y times A over 2 equals R times, what was this one? It'd be, let me see, R times, yeah, C over 2. Now that we know this, we can use another method. Now, we're going to start factoring these things, and we're going to do this. So we're going to factor these. I'm going to do this by multiplying 2 to the bottom, because everything has 2 in the bottom. This is going to do the following. Let's go this way. I need a different color. Yeah, let's go this way. For number 1, it's going to do times 2, so y times c plus z times b equals A times r. For number 2, it's going to do a times z times a plus x times c equals b times r. For number 3, it's going to do x times b plus y times a equals c times r. Now let's move on to the next page to continue this fact. We're going to factor all of these by putting them together and grouping the r up and the x and y's up. We are going to do this by the following method. We're going to further factor them by grouping these up. But before we do that, we need to add these 3 equations. Okay, we're going to add these 3 by using a simple systemic equation of 3 equations. We're going to do that by this way. We're going to add all these. We know that it goes straight down. So yc plus zb plus za plus xc plus xb plus ya. That's 2, 4, 6. Correct. A plus r. No, a times r. br and cr. Now that we have that, we can actually now factor. No, not factor, but group. We're going to do that by doing A, B, C's on this side. A, B, C's. And this side, we're going to factor by R because it's all common. With that, we'll get R, A plus B plus C equals let me see, Y, Z, right? We have Y and Z. Y plus Z. We have B, X plus Z. We have C, X plus Y. Yep. Now we're going to do a rearrangement of these. We're going to put the X's in groups, X and Y's and Z's in groups for this one. So rearrangement to make it more nifty. We're going to do that by making X the owner of B plus C, Y the owner of A plus C, and then Z the owner of A plus B. Then we have R, A plus B plus C. So what we can do right now is using another equation known as the semi-perimeter of a triangle. We know that the semi-perimeter of a triangle is 2 over its perimeter, which currently is A plus B plus C. Then we can also say that 2 times that is equal to A plus B plus C. Using that, we're going to substitute this value into this side of the equation first. Let's move on to the next part, next page. Let's move on to the next page. Let's resume. We're going to do this by substituting as mentioned, which is X. So we have B and C here. If B plus C equals 2x minus A, right? So we're going to substitute 2x minus A into this slot. So let's do these substitutions. Then X will become 2A minus A, 2S minus A, plus Y will become 2S minus B, and Z will become 2S minus C. And R will remain the same for the moment, for the proof to continue. We're going to expand on these ones, which will be 2xs minus xa plus 2ys minus yb plus 2zs minus zc equals r a plus b plus c. Now we're going to group these up again using the 2s we have. We do this by grouping these ones, x plus y plus z minus xa minus yb minus zc. And we also know this equation from before, so we're going to change that, substitute this one with 2s. Then r will become 2sr. Okay, now we're here. Let's go farther with another equation. Now, at this point, we're going to use another theorem we know, which is the area of a triangle. Now we're going to use this equation, which is area equals area times inner radius times semi-perimeter. And from this equation, we can get that the semi-perimeter is x plus y plus z over 2, and that multiplied by the inner radius is ax plus by plus cz over 2. But we're going to multiply that by 2, so we can get 2rs, which is going to be this times 2, which equals ax plus by plus cz. This is to get rid of this, these guys. Let's group this up first so that it's more cleaner. To this, to x plus p. So this ax plus y plus cz equals to sr. Then we can substitute 2r's for this one. Then we're going to get 2s x plus y plus z a plus 2rs equals to sr. Now we can get rid of the s's by grouping them up and dividing them, which is going to get us 2x plus y plus, let's go with 2s so we can get rid of all of these. 10. Then we're going to get x plus y plus z minus 2r equals r. No, r equals r. Then we can finally get to the result that x plus y plus z equals r plus r. This is the outer circle. Outer radius, well, should I say the circumcenter's radius, and then this one would be the inner radius. Now, to put this in a drawing, and let's magnify this up, and let's make this more clear. Resize, make it bigger. To put this in a drawing, since x plus y plus z equals r plus r, we can actually say that this length and this length, let's see, sorry for the bad drawing, yep, this length, for this is going to be another r. This length, oh my god, we can say that this length plus this length is equal to x plus y plus z. That is the Carnot theorem in an acute triangle. Okay,